Now that we have an understanding of the differences and similarities between prototype theory and exemplar theory, I want to reiterate that there is evidence, empirical evidence for both theories. So here's an example of evidence that favors prototype theory. So Keel, Reed, and Posner did an experiment that provides prima facie evidence that people extract prototypes when they form categories. So they showed subjects 5 schematic faces. One fell under category 1, one set of 5. The other set of 5 fell under category 2. The subjects then were asked to categorize 25 new faces within 12 seconds, according to category 1 or category 2. Now, the model that best described the subjects' classifications, as well as their introspections about what was important to them, was a kind of prototype model. And so it provides evidence, prima facie evidence, for prototype theory. And this, of course, you'll recognize as a transfer experiment, an experiment where you're given a bunch of exemplars, and then you're asked to transfer your knowledge from those training exemplars to novel cases. There's evidence for exemplar theory as well. So, for instance, researchers also presented faces, and what they did in this case is they presented faces in which the most frequent feature values differed from the average values. So remember, prototype theory is looking for the central tendency. It's looking for the average value for the most common properties across that class. And so prototype theory predicts that subjects will respond most favorably to faces with average feature values. In some cases, people classify novel instances with frequent extreme feature values as category members more often than the supposed prototype. So here are the faces that were shown to subjects in this experiment, or at least some of the faces. So we have face B that represents one prototype. We have face C that represents another prototype. And the subjects are asked to, in effect, categorize to say which is most similar. Now, if the features are independent and additive, then people should say that face A is most similar to face C. Why? Well, face A differs from face B in 2 features. The ears are smaller and the nose is larger. Face A differs from face C only on one feature. That is, the nose is smaller, but the ears are the same. So prototype theory predicts, hey, features are independent and additive. If I've got 2 feature differences and I've got 1 feature difference, the thing I have 1 feature difference with is the thing I'm most similar to. In fact, the subject said that A was most similar to B. So this suggests that there was something else going on besides just independent and additive features when we're doing similarity judgments. And in fact, this particular experiment illustrates one of the general difficulties for prototype theory. And we're going to talk about a number of difficulties for prototype theory and for similarity theories generally. That last experiment illustrates a difficulty with prototype theory and really to some degree with exemplar theory, in that noses in that example are much more salient than ears. So differences in ears didn't matter so much as the difference in the size of the noses. So face C had a very small nose. Face B had a nose which was larger, not quite as large, but it was closer. Right? And that overrode the other difference. So how do we decide? How do we understand within these frameworks for similarity views, especially prototype view, how it is that features get to be salient and what's the most salient aspect of those features? In this case, noses just seem to be more salient than ears, but there's no reason if the features are independent and additive for that to be the case. We've got 2 ears and just 1 nose, and they're statistically identical in their frequency. That's just as many ears as people with ears as there are people with noses. The next problem we're going to look at just has to do with the informational limitations of the idea that in learning a category, I abstract the central tendency, the single representation of the average values of the most common features. Then we'll look at the notion of concept combination, whether or not we can predict how typical something is when it combines two concepts in an instance of an example of another concept. Then we'll look at cases where prototype theory predicts a particular learning outcome when in fact that learning outcome just can't be seen in the empirical results. Then we'll look at two general problems for similarity theory, clearly problems for both theories, namely context effects, why it is that how we categorize objects differs from one context to another, even though there's no mechanism in a list of features that accounts for that, or at least easily accounts for that. And the last one, that there are extra featural factors. There are other things besides just features that seem to drive categorization in many instances. So in general, remember, a prototype representation extracts that central tendency, and in doing so, it discards a lot of information. It discards information about the category size, about the variabilities of the examples, and about information concerning correlations between attributes. Now, each of these deletions can pose problems for categorization when such information seems relevant. So, variability is nicely illustrated by the example of the dog concept, where dogs differ dramatically in the features that they exhibit, but we don't seem to be bothered by that in our categorization. Here's another example of this, correlation of attributes. So prototype theory incorrectly predicts the typicality of combined concepts in many cases from the typicality of constituents. So for example, if you ask people what's more typical, small spoons or large spoons, they'll overwhelmingly say that small spoons are more typical than large spoons. And then if you ask them what's more typical, metal spoons or wooden spoons, again, they prefer metal spoons to wooden spoons, though this isn't as profound. Now, this should result in an ordering, a prediction of what is most typical to least typical for the combination of these two features. So small metal spoons should be the most typical. Small wooden spoons should be next because size is favored more than constitutive material, followed by large metal, followed by large wooden. However, people judge large wooden spoons to be in that second slot. In effect, the least typical thing is the second most typical thing. So there's a little joke for you to break up the lecture a bit, but this is a problem. It's a problem because we should be able to predict the typicality of these two things that just combine two features based on the typicality of the features themselves. And in some cases we can, but in many cases we can't. Now we can use we can use exemplar theory to explain these cases by supposing that we have two exemplars, one a small metal spoon and one a large wooden spoon. But when we confront the empirical evidence, we have to suppose existence of things to explain all of these different divergences. Every divergence is going to have a separate exemplar, and there's no mechanism for determining when that's legitimate and when that's ad hoc. So we'll pick this up in the last module of this lecture.